Cool. Hello, everybody. Wow, I'm loud. Welcome to Building Massive Online Worlds with SpatialOS and Google Cloud Platform. My name is Mark Mandel. I'm developer advocate for Google Cloud.
And I'm Rob Whitehead. I'm CTO at Improbable.
Cool. So before we get started, let's get a sense of the room. Hands up the people here who are game developers. Ooh, more than I expected. Hobbyist game developers. All right, cool. People who are into like simulations. Ooh, some, yeah, simple Venn diagram. Cool. People who are just interested because this seemed cool. That's fine too.
Awesome.
Awesome. All right, fantastic. I'll tell you what, since we're here, Rob, thank you so much for joining us. I really appreciate you taking the time to talk to us about SpatialOS. So that everyone has a sense of what it is we're talking about today, why don't you give us like the general overview of what Improbable is and what SpatialOS is all about?
Yeah, for sure. So we're Improbable. We're a group of about 150 of us distributed across London, San Francisco. And our goal is really kind of building a platform to let you kind of go beyond the traditional limits of a single server to build massive living simulated online worlds, either using them applied to kind of video games, like you can see in this video, or using them to like understand the real world, like simulating a city or an ecology. So what's going on here? This is an example of a game built with one of our partners called Adrift. And this is a massively living online world, which is running in the cloud, and it's powered by not just a single dedicated server, like traditional games are used to, but actually hundreds of game engines cooperating and overlapping together to simulate a world much bigger than any single one could ever deal with. And connecting into it are thousands of different players all across the world. Again, like sort of more than a single dedicated server or VM could ever deal with.
Jumping out of YouTube is always fun. Awesome. So you may be wondering like why we're talking about Improbable and SpatialOS at Google Cloud Next. So the answer to that really is that Google Cloud Platform is always looking for new partners that share a desire for innovation, and especially innovation in the game space. We really want to partner with people who want to let people build, oh god, I'm going to say it, really what's next in the gaming world, and really just across the board as well. To that end, we're actually really happy to be partnering with Improbable to help them develop the SpatialOS Games Innovation Program. Rob, can you tell us about how that goes?
Yeah, for sure. So when we kind of went out into the games community, we found there were these fantastic ideas people had about leveraging this amount of cloud resource to build like the next generation of like simulated living game worlds. And we found people a bit apprehensive in terms of the cloud costs that they might incur in terms of their development and R&D. And Google and Improbable got together, and the innovation program allows us to offer like free development costs in terms of cloud for people from starting development all the way through to commercial launch. So the idea is to kind of like sort of allow people to like kind of let loose and experiment and try and do some crazy things without being worried about kind of the cost they're going to incur to do that.
So that sounds pretty cool. Why don't we check out how that actually works?
Awesome. So I'm going to kind of talk on a high level about our platform as a service and its kind of core architecture and how you think about it and what the abstraction is on top of traditional servers. Then I'm going to give you an actual live demo on my laptop of it running on my local machine. And then we're going to dive into some code snippets and kind of show you under the hood. For those of you who've coded with Unity 3D, you might find some of the APIs quite familiar. Who's actually used Unity, out of curiosity? Great. So for those of you who kind of may be aware, traditionally when you have online game worlds, they'll have a dedicated server. And that's a process running inside either a dedicated server somewhere on a bare metal hardware or on a VM in the cloud. And all the clients within that world connect into that single server. And this works pretty well when you have a small amount of concurrent players, or if you have a small amount of simulation going on, if your world's not that complex. But you encounter issues when you want to have thousands or tens of thousands of people in the same environment, and you want to have worlds that are truly living. If you want to have a game world which has millions of trees which actually grow and like a real ecology and a real economy, you kind of start to hit the fundamental limits of a single machine, no matter how many cores you get. So the whole idea of SpatialOS is it's a distributed operating system. So that is to say, it's a abstraction on top of lots of computers, lots of VMs. So at least you treat of it as one big machine in some senses. And the core idea is rather than having a single dedicated server, which you'd normally have, Unity compiled out as a Linux dedicated server or Unreal's dedicated server, SpatialOS actually orchestrates a swarm of dedicated servers, potentially hundreds of thousands of them, all with overlapping areas of interest, all kind of combined together to simulate a massive game world.
Cool. So basically, kind of what you're telling me is it's kind of like a traditional platform as a service, but just for massive online persistent worlds.
Yeah, exactly. And you think about, and the whole reason we call it SpatialOS is you think about this big cluster of machines as a three-dimensional space, which contains your computation.
Awesome. So as a developer then, what does the lifecycle look like? How am I building my stuff?
Yeah, for sure. So it's, again, a traditional kind of platform as a service style use. You have a set of CLI tools and web tools you download from spatialos.com. You can do this today. You could do it right now. You should listen to us instead, though. Once you downloaded those tools, we have integrations into Unity, into Unreal, and we also have base language integrations, so you can write code which works in this manner in C#, C++, Java. And then you use some CLI commands to package up your application, push it into the SpatialOS platform, and then, like sort of on our side, we're going to be using as much computation as is necessary to simulate your world. So these are the kind of core words which you use when you're thinking about building something with SpatialOS. And some of you might find some of these words familiar because they're very much inspired by game engine architecture. And some of you might find that, like workers is a new word we've kind of invented, but it's actually a broadening and an abstraction from things you're probably already familiar with. So in SpatialOS, the core idea of the world is it contains entities. It contains things. So in a video game, like you saw Worlds Adrift before, each player is an entity, the rocks on the floor are an entity, the trees which can be chopped down are entities, and even the ships are actually composed of hundreds of entities. So they really represent the domain of your application. You can imagine if you were using SpatialOS to simulate a city, you might use entities to represent road segments, buildings, traffic signals, all kinds of different things. Then you have components. So this is like a traditional structure of game engine architectures. And what it lets you do is, rather than having like sort of really big monolithic ideas of objects, it lets you compose them out of pieces, which make it a lot easier to reason about. So rather than thinking about a monster, you think about something which is a rigid body, which means it can move in physical space. It has a collider, which means it can bump into other things. And it has a navigation component, which defines the idea of it having like a destination to go to and some waypoints along the way. So the interesting thing here is workers. Workers are, I guess you can think of them as like microservices, little pieces of code which either are connecting in over the internet, like a game engine client, or running within SpatialOS itself, which are authoritative over parts of entities, as in their components. So you can imagine taking a physics engine like PhysX and having that simulate all the rigid body components of the entities in the world. But the magic which is going on here is maybe PhysX can only simulate 10,000 rigid bodies, and your game world has 1 million rigid bodies. What SpatialOS can do is actually spin up 100 instances of that process distributed across the cluster and have them all cooperate together. And SpatialOS is handling all the synchronization and all the orchestration that's going on for you. So to kind of like sort of bring it back into a concrete example based upon the video you saw with Worlds Adrift. From their side, within one of their worlds are about 50 by 50 kilometers, and you're looking at kind of over 500,000 fully physically simulated objects inside that game. So creatures, players, panels of a ship can fall off and fall onto the ground and be completely persisted. Each one of those islands you saw are kind of built out of like voxels through like a user-generated content tool. And those islands themselves have about 3,000 entities, from even like an egg on the ground or a tree. They're all entities. And every single one of these entities is fully persistent. So the whole idea is SpatialOS maintains the data representation of the world completely distinct from any one of these processes or clients connected in. So if you drop a sword in a bush and you kind of come away, you should be able to come back to it, and years later it should still be there. And this is because you can think about SpatialOS as an in-memory database, which is maintaining all those entities. And in terms of examples of components inside of Worlds Adrift, some of them are kind of very familiar, you might find if you're a game dev, but within Worlds Adrift, they're actually a real ecology of creatures, and they even have components about pregnancy and how hungry they are. And it's really crazy how much depth you can go into to define those entities. And then in terms of workers, you have your workers running in the cloud. So for Worlds Adrift, they have 200 Unity Linux instances all cooperating together to simulate the space. And they have about 1,000 Unity clients, which are players connecting in all across the world to simulate the world. So again, something massive and far bigger than any single game engine could deal with.
Awesome. That sounds really great. So why don't we cut to the demo, and you can actually show us this thing in action.
Yeah, for sure. So this is where it gets really fun. So it's worth saying, SpatialOS is a platform as a service. It's a tool which lets you run large-scale simulations in the cloud. But often for local development, it's convenient to have a local SpatialOS. And SpatialOS can use, a single machine, or it can use 1,000 machines. So what you can see here is it using just a single machine on my local machine. And we're going to be using a tutorial which is available online right now for our Unity integration. So let's go ahead and start it. So yeah, the idea of this sort of demo is it's like a little diorama of SpatialOS. It's going to show you the core concepts at work. And although we can scale to maybe hundreds of thousands times larger than you'll see here, it'll really kind of leave you with a feeling of kind of what's going on under the hood. It's working.
Good.
So what I'm going to run here on my local machine is a traditional built-out Unity client. And I'm going to be running around as a awesome little wizard, which is going to be able to go around and set things on fire, which is going to be really, really cute. There we go. So, this is pretty much like sort of a any kind of game you might be familiar with. And this little guy, I can go around, I can see things going on, I can set things on fire, and I can also set the little people on fire, which is not very nice to do, but I can. And it's it's definitely going to happen, I'm sorry. Oh, I missed. But you'll see it's just like any other game. But already kind of what you should see here is the game world is actually much bigger than what's inside this single Unity client. The world's actually contains like tens of thousands of trees, and there's actually another base very similar to this on the other side of the world. But what's happening is as I move around, you kind of won't notice it, but the subset of the world I'm interested in is being streamed in by SpatialOS. And this client, the simulation of those little dudes running around isn't actually being done on my client. It's being done on a built-out, dedicated Unity server running on my machine, which is connected into SpatialOS. And this client, rather than being connected into the dedicated server, is connected into SpatialOS. And SpatialOS is managing the interests of the worlds that go around. OK, I'm going to have to get really accurate with this now. Come on. No, I missed. It's all right. We can come back to that later when there's more people. So the first thing which I want to show you is that's kind of what the game client sees the world as. But I want to show you what SpatialOS sees the game world as. So this is the entire space. Again, it's a relatively small simulation. It's about 10,000 entities. And already you can see that we're actually running not just a single dedicated server, but there are actually 2 dedicated servers running and overlapping together to simulate a world kind of much bigger than a single one could deal with for an extended period of time. And if you zoom in here, you can actually see this overlap area. And what this is showing you as well is the canonical data representation of the entities inside the world. So although Unity sees them when you log in as a client as these really high fidelity or graphical assets, you can see here I can go ahead and click, and this is a tree. And if I go ahead and click on it, it can actually show me the components of that entity. And this is really important, having this agnostic representation of the world, because we don't care whether the game engines and dedicated servers have been written in C# or C++ or Java, or whether you've used Unity or Unreal. This is this kind of canonical, agnostic representation of everything going on. So we can already start to do some fun things, which are really scary to do on stage, but actually work out pretty well. So one thing which happens when you're running not 2, but 200 or 2,000 game engines is in the cloud, sometimes they'll crash. Code, it has a mean time to failure. So if I go ahead and pull the power cord out of one of these workers, what's going to happen is if you actually zoom in, you'll find the top right-hand side of the world is actually still being simulated, but the bottom left is actually paused. There's almost like a glitch in the matrix. But if I zoom out, you'll find that SpatialOS detected the failure, and it's actually started up a new worker to replace it in this top left-hand corner. And what we're showing off here is our dynamic load balancing algorithms, whereby 2 workers can actually change their spatial area of interest in real time to deal with fluctuations of load. So if you have a really big epicenter of combat going on, you can actually have a worker move to that area of space and shrink in and kind of focus on what's happening. Cool. Let's go back and see if there's more NPCs to have fun with. Yeah, there's a lot more. Oh no. Oh no, that's a really bad idea. That's right, one of my friends put me out, clearly nicer than me. The other thing to show you here as well is, if I zoom in here, this is actually showing the subset of the world which the client is actually connected into. And the little blue dot, if you can see it, is my player. And as I move around the world, SpatialOS is understanding the subset of the world I'm interested in. And it's going to go ahead and move like a window of interest within my world and streaming it in. So this is, again, demonstrating you can have game worlds substantially larger than any single instance of Unity could ever deal with or fit inside of memory. And as you move around, it's actually like streaming in just a subset of the world you're interested in, and it's going to be keeping you up to date there. Cool. So that pretty much concludes the demo if we want to dive into some code examples.
We can switch back, please. Thank you. All right, that sounds really great. So yeah, let's have a look at some code examples, and you can kind of talk us through how the actual coding aspect of SpatialOS works.
Yeah, for sure. So the first thing to talk about here is the SpatialOS schema language. So I talked before about SpatialOS having a kind of canonical data representation of the world, which is completely distinct of any language or any kind of client or any kind of server like microservice or kind of game engine connected in. And this is how you define that. So this lets you define the abstract idea of a entity without any understanding of its implementation, which gives you the flexibility to use whatever tools you want. So this example here, I'm going to show you the implementation of flammability within Unity. And it starts off by defining this canonical abstract idea of a component. So I'm going to call it flammability, and I'm going to give it the idea of a property being is on fire, because obviously I want to have some state for is this thing like sort of not on fire or on fire. And the thing I'm going to add as well is a command. So commands are SpatialOS's RPC mechanism, which lets two workers communicate with each other. And I'm going to define a command here called ignite, which is if I'm something which is on fire and I'm something which is not on fire, I can send an ignite command to the thing which is not on fire and make it ignite. And the awesome thing Spatial is doing for you is it's going to automatically route that RPC to whatever worker is authoritative on that component at any point in time. So you have this kind of really nice transparency going on. And if it turns out you're the actual worker who's authoritative for that command, it's going to short circuit it, and you're going to get like sort of that efficiency already built in. So this first part of the example is going to be about our implementation of the Unity server code. So this is the code running inside of the workers you saw before, the two overlapping processes. And those of you who are kind of who's written like sort of Unity code before in C#, any chance? Yeah. So you'll see something here which is quite familiar, which is a Unity mono behavior. And the thing which is cool and the thing which is new is that first line where you see require flammability writer. So SpatialOS's SDK has a really powerful code generation tool built in, which takes those components you defined in the SpatialOS schema language and generates idiomatic APIs in whatever kind of platform you're writing clients or dedicated server processes for. So in Unity, it's going to go ahead and write these classes which demonstrate the ability to read and write from a particular component. In Unreal, we'll actually generate UActor components, and you'll be able to use the Blueprint visual scripting tool to actually wire up and do things that way. Or if you're kind of writing like a small C# microservice or something in Java, you're going to get, again, some like sort of relatively straightforward APIs which you can use to hook into the different parts of an entity. And the first thing I'm going to do in this sample here is add in a implementation for ignite. So this is saying when someone tells me to ignite, here is an implementation of the callback to call. So this is the next bit of code. So those of you who kind of aren't familiar with Unity, it has an idea of a trigger. So this is a collider which you can actually walk through. But when you walk through and into it, it's going to fire an event to tell you that somebody's kind of gone into it. And this is a really good tool inside of Unity for dealing with objects kind of moving within proximity of each other and you getting alerted of that. So what I'm going to do is I'm going to use the trigger system of Unity and kind of tie that into SpatialOS so that when somebody moves into my trigger region, I'm going to check, am I on fire? And if I'm on fire, I'm going to send the thing that moved into my trigger region a command. And that command is either going to, what SpatialOS is going to do for you is it's going to work out, is that entity on my worker locally? Am I authoritative for it? Then I'm going to invoke the command locally. If it's not, it's going to send it through SpatialOS, and it's going to work out whatever worker across the cluster is authoritative for that entity, and it's going to invoke that RPC. And it's worth noting here, I didn't write any kind of serialization code. I didn't write any data synchronization code. It's all handled for you. You just kind of invoke this method, and we're going to choose the most appropriate thing to do. And the final thing to see here is the ignite handler. So this is when myself, I've received an RPC from somebody to make myself ignite. And this is the implementation I've defined in Unity code on the dedicated server to handle that. And what you can see I'm going to be doing here is checking, am I not on fire? If I'm not on fire, I'm going to send a new update, which sets me on fire. So when you do that .send, what's going to happen is that dedicated server worker is going to send a message into SpatialOS, all for you. And SpatialOS is going to work out exactly what other workers need to know about that property update. So maybe there are 1,000 clients all watching this tree, like really excited for it to spontaneously set on fire. And when that, pyromaniacs everywhere, when it ignites, SpatialOS is going to do that kind of distributed synchronization across all those different workers. And those workers might be running on different machines across the world. They might be running on different machines in the cloud. We handle that kind of big synchronization effort. And you didn't write any network synchronization code. You didn't write any kind of any kind of reliable UDP stuff going on. We're using like sort of best in class, like sort of transport stuff to go ahead and do that for you. And then this is the kind of the fun bit, I guess, which is, although SpatialOS, one of the core ideas of it is that it maintains for every component of every entity, there is only ever one worker, which is authoritative for it, which really helps in terms of race conditions and that kind of thing. There may be arbitrarily many workers interested in reading a component. So you could imagine there being thousands of clients, again, like interested in that tree. And what you use in this case is rather than injecting in a flammability reader a writer interface, you inject in a reader. And this reader is going to give you callbacks for being told when the component data of that entity is updated. So what I've done here is, when I enable, I'm adding on a visualization update. So I'm going to make a callback for when this object either becomes on fire or ceases to be on fire. And then in classic Unity fashion, I've got a particle system, which I've kind of like sort of got wired up here. You can imagine it being inside of a game object inside of Unity. And based upon the abstract idea of SpatialOS, its flammability being on fire or not on fire, I'm going to go ahead and actually visualize that with a particle system being enabled and disabled. And this is a really nice decoupling. You might be familiar with it if you're kind of from the web dev world, of your model being decoupled from your view. And this is really nice because this Flames visualizer is the one which is used on trees, but you can imagine the one which is being used for NPCs with them kind of flailing around their hands in a really cute and terrifying fashion is a different piece of code. So it lets you kind of really nicely compartmentalize the implementation of a component from the visualizations which might take place on different kinds of client. And you could even imagine the visualizer code on a mobile device, which is connected into the same world, might use a sprite rather than a full-on particle system.
Cool. So, I mean, you showed us a bunch of Unity code, just so we're all aware as well. Like, this works on Unity, this works on Unreal, you can run on custom engines.
Yeah, exactly. So, as I said before, the APIs we generate, we have really, really deep integrations into Unreal and Unity, which lets you have these really nice idiomatic interfaces. But if you want to write just a microservice to do something like, say, A-star pathfinding for your kind of NPCs moving around, you can use our kind of lower layer language worker integration instead.
Awesome. All right, so we are here at Cloud Next, obviously. So not only is it great to hear from you about SpatialOS and how it works, but I'm guessing there's some people in the audience who may want to hear about like why you're with us. Why are you with Google Cloud Platform? Excellent. So I know you use a few different products of ours on Google Cloud Platform. The first of which is Compute Engine. So I know from my perspective, developer advocacy, quite often I speak a lot about like the cool new shiny stuff or the stuff that automatically scales like App Engine or something like Kubernetes. But you use a lot of virtual machines on Compute Engine. So if you're not familiar, like Compute Engine, those are the virtual machines that run on Google Cloud Platform. You spin them up, spin them down. They're very traditional in what they use. Can you talk about your experience using those?
Yeah, for sure. So for clarity, SpatialOS itself is a platform as a service, which means you have an account with your SpatialOS, and you use those CLI tools to kind of deploy to the cloud. But under the hood, we're actually using Google Cloud's actual like sort of infrastructure to be able to run and scale your simulation. And when we were choosing like cloud providers to run on, we found that Google Cloud Platform had some favorable characteristics for certain kinds of things we use. So when I talked about Worlds Adrift running before, it's actually running about 500 cores worth of compute across about 50 machines. And they're actually good old VMs running on Google Compute Engine. And when you type in spatial deploy, which is the command to actually go and start your simulation, what we're doing under the hood is actually starting Google GCE VMs to actually be running the power and the kind of the workhorse of all the simulation going on here. So the thing we actually found with Compute Engine, which made it really good for our use cases, is we want small teams to be able to iterate really fast. And we want you to kind of come up with a really crazy idea for a multiplayer game, write some code, and then just run it in the cloud, and then share a link with your friends, and then you can all log in and play it. And the provisioning time of a VM, which is the time you say, hey, I want a VM, to here is your VM, is a really important part of that iteration process, especially when you're working with teams. So the awesome thing about GCE for us is the provisioning times, which we found to be really quite favorable compared to other cloud providers. And what that means for you as a SpatialOS developer is you get that faster turnaround time, and you can experiment quicker.
Cool. And I think you were also looking at custom VMs. So if you're not actually familiar with those either, Google Cloud Platform gives you the ability to create VMs with exactly the same number of CPUs, exactly the number of CPUs and memory that it is you want to use. And I know that that works very well for you as well.
Yeah, this is something we're kind of investigating right now. When you imagine running a game engine like Unity in the cloud, you want to make sure that you don't have any memory you're not really using or any CPU you're not using. And from that side, if we can better pack Unity instances onto VMs, it's cheaper for us to run, which means we can make it cheaper for you to use. And that's a really powerful tool there, especially because game engines are quite weird beasts when they run in the cloud, and they have quite strange kind of resourcing requirements sometimes.
Awesome. So when you and I got together and started talking about this, we also started talking about the Google Cloud Platform Network, which I don't know if we necessarily talk about as much, but I think is really cool and interesting. So for obviously, or possibly not obviously, we run on the same infrastructure as, say, Maps and like Gmail and all the other Google services. And as you may have heard from all the stuff that's been going on around Spanner, the network that runs Google Cloud Platform enables us to do some really cool stuff and is exceptionally fast. I think you've had a pretty similar experience running your stuff on Google Cloud Platform's network.
Yeah, indeed. So the first thing about real-time multiplayer games, which is quite different than traditional applications, is rather than kind of using TCP as the underlying transport, a lot of them are based around UDP. And that's because when you're receiving a fire hose of, say, 60 updates a second of a player position, if you drop some of those packets, TCP is going to go ahead and go, hold on, and you're going to get these delays whilst it tries to reassemble and give you a reliable stream. But with a player position, I'd rather just get the next position if I miss one. And UDP is a natural kind of choice of transport for that, and it's basically best in class for the industry. And what ends up happening is people end up, there's really popular open source libraries like RackNet, which are abstractions on top of UDP to give you semi-reliability. So you can imagine a position update of one of those panels falling down in Worlds Adrift is actually being sent unreliably with UDP. Something like one of those RPCs to Ignite is actually sent reliably. So RackNet lets you kind of you can turn the dial from sort of fully unreliable to fully reliable. And in terms of how that applies to sort of Google and its networking, cloud providers, I guess traditionally were really built around scaling web services. So I've got some SaaS to Facebook for Dogs or something, and I want to kind of scale out the front-end web servers which are hosting that. And when we went ahead and tried to start using cloud providers for UDP, especially like fire hoses of UDP packets, you'd find there are limitations in terms of especially with small UDP packets, how many of them you can send per second on a single VM. And when we were kind of profiling around, we found Google's networking had a really solid kind of performance in terms of being able to, I think, send like hundreds of thousands of packets a second from a single VM. And that really translates into being able to have richer, bigger, more interesting worlds and have more players packed onto a single server, which is an important part of having really dense combat and really interesting gameplay. And yeah, it's worth saying as well that we use sort of clusters all over the world. So we have clusters in the US, we have clusters in Europe, we have clusters in Asia, and they're running on Google Compute machines, but people are connecting over the internet using Google's networking infrastructure to connect into those SpatialOS deployments.
Now, something we don't probably talk about that often necessarily in the game space is storage, right? So you also do really neat stuff with Google Cloud Storage. So again, if you're not familiar with Google Cloud Storage, this is the place for you to store binary files on our system. The nice thing about it is that we have nice things like edge caching. You can store petabytes of data on it. It'll do regional and multi-regional replication for you out of the box. So it comes with a lot of good stuff. But I've seen you use it in kind of interactive ways. It kind of works really nicely.
Yeah, it's really cool. So you saw before what SpatialOS sees a game world as. It sees it as just dots in a kind of arbitrary three-dimensional space. But when you kind of walking in your game and you encounter an object, maybe it's an object you actually haven't seen before. SpatialOS doesn't actually contain in its in-memory representation the actual mesh data and like sort of the assets which represent that object. All it contains is a pointer into Google Cloud Storage, which contains the actual Unity asset bundle you download. And this makes a ton of sense because SpatialOS is optimized for high amounts of kind of data throughput. It's optimized for components updating maybe hundreds of times a second. We don't want to be storing kind of blobs of megabytes or gigabytes of data in that thing as well. It doesn't make sense. So we kind of have this tandem thing which makes sense. So when you kind of fly around in a ship in Worlds Adrift and you see an island you haven't seen before, what's going to happen is SpatialOS will say, oh, that island is called island 4709. And then using SpatialOS as APIs, you can actually hook into our we call it our assembly service, which is going to fetch to you from Google Cloud Storage the appropriate island for you to download as an asset bundle, stream in real time using your game engine, and spawn into the game. And when we kind of were choosing GCS, traditionally you'd kind of think that you need to use a CDN for this kind of thing, but we actually profiled GCS against like sort of conventional CDN providers, and we found it was comparable. And we were using this anyway for like sort of how we store a lot of things within Spatial. So yeah, it made total sense for us.
Fantastic. So you're using a bunch of products from Google Cloud Platform, which is great, but you're also using some open source stuff as well.
Yeah.
You're actually using one of my favorite open source projects, gRPC. So gRPC is a high-performance open source universal remote procedure call framework. It came out of Stubby. So it came out of historically our internal remote procedure call framework called Stubby. It's really, really cool, works really, really fast. It does streaming data really, really well. It's been a huge thing around how we talk about microservices at Google and Google Cloud. Can you talk about how you've been using it? I think it's really interesting for games.
Yeah, for sure. So you can imagine with games, bandwidth is absolutely key and performance is absolutely key. You don't want to be fire hosing around like JSON blobs, which represent entity position when you're sending hundreds of them a second per entity, and you might have 1,000 entities in your scene. And also, like sort of when you're running like sort of like Improbable, we have a team of like around like sort of 100 engineers. We have a constellation of different microservices that make up SpatialOS. So besides the actual runtime, which is this kind of in-memory spatial simulation representation, we have microservices for things like accounts, billing, storing deployment snapshots of your world, storing like the binary assets you kind of download, like your trees, etc. And we reached a point where we were using kind of like a RESTful interface for all those things. But you start to have a lot of issues arise because you don't have a typed representation of that interface, and you start to have teams like stepping on each other's toes, and you have to rely on like large amounts of unit testing and integration testing to actually make sure your software works. But under the hood for us, we use gRPC for all of our microservice architecture, and actually with Spatial, if you type in spatial deploy, that's actually using gRPC calls to talk to our platform to kick off that deployment. And another thing we actually have in the pipeline as well is that inspector you saw, that kind of WebGL accelerated entity view. When you kind of move it around, it actually sets up a streaming query for a subset of the world to be streamed down into the browser. And again, gRPC looks like a really powerful candidate to kind of help accelerate that as well. And it's kind of based on HTTP2 as well. So it's really nice for kind of lots and lots of like sort of requests and responses really quickly, and also for streaming responses.
Fantastic. Sweet. So you've shown us some really amazing stuff. Super excited about SpatialOS. I think it's really exciting tech. Can you tell us about what plans you have for the future? What can we see? What's coming up down the pipeline?
Yeah, so there's kind of two different angles to talk about. So the natural first thing is about scale and performance. We really want to be this platform where you can have game worlds or even simulations of the living world, which are kind of reality scale. And by that, we mean millions of concurrent players in the same environment with high fidelity physics, maybe even in VR. And billions of simulated entities which have rich AI, they're fully physical and they're fully persistent. And all of our dev teams at Spatial, especially on our R&D side, are focused on trying to push the capabilities of SpatialOS further and further. And that really comes down to how many clients you can have in that world, and also how many servers can participate in this single, uncharted, seamless spatial computation. And I'm really excited to kind of see the direction we go in the next couple of years there. We kind of want to build the matrix. That's probably something we push. It's a story for another time, but that's kind of, you can imagine the foundations of it based upon that. And then the other side is now we're kind of friends with Google is looking at the constellation of tools and services they have and how people could easily tie them in working with SpatialOS to do some awesome new things. So you can imagine a game world which is like a successor to a Pokemon Go geo game where you're using Google Maps data and streaming that in and using Google Maps objects to represent SpatialOS entities. That could be really exciting. Or on our kind of non-gaming side, doing city simulations that are actually based upon Google Maps' like sort of traffic information and building information. Be really exciting. We have some like sort of interesting angles we're looking at with kind of YouTube and how streaming plays a part in real living worlds. And I think there's some exciting stuff we can talk about soon on that. And then kind of, again, another kind of Skynet-esque kind of thing to think about is integrating in technologies like TensorFlow into spatial. So I talked before about the workers that connect into SpatialOS can be completely arbitrary. So I had a hackathon team a few weeks ago, and they actually integrated a C++ TensorFlow worker running in interactive mode into SpatialOS, and was doing reinforcement learning of these little entities kind of moving around and eating things inside of spatial. And they were kind of sharing the same brain, so as you had multiple entities in the same world, they were actually combining together their learning information. And I think the idea of SpatialOS as almost like a kindergarten or a sandbox for AIs to learn about like physical systems and learn how to interact is a really exciting proposal as well.
Fantastic. All right, well, we're going to have plenty of time for questions, which is great. First of all, Rob, thank you so much for joining us on the stage. But before we go, do you have any final thoughts or like the one thing that people need to remember about SpatialOS before they end up leaving the room?
Yeah, it's not crazy magic technology. You can literally go to spatialos.com right now. You can download the SDK. You can play around with it. In terms of what you can use it for, you can use it with Unity, and you can like sort of be running things in the cloud. You can be using Unreal, and yeah, you can also be using like whatever language or whatever tools you're familiar with. They're very easy to integrate into SpatialOS's representation of the world. And in terms of the two things we want to let people do with spatial on the gaming side, one is teams, like no matter how big or small they are, being able to do fundamentally new kinds of things in the game industry. So game worlds which are like truly persistent, have millions of living objects inside of them, tens of thousands of people inside of them simultaneously. We want to make that possible. And also because SpatialOS is a platform as a service, we want to take small teams like Bossa, who don't really have an infrastructure team. They don't have network programmers. They don't have all the people you traditionally expect you need to build persistent worlds. They're going ahead, they're picking up SpatialOS and its Unity integration, and they're doing things which really they'd find like fundamentally impossible, or they need to hire beyond their means to make it possible. So it's about everybody being able to do fundamentally new kinds of things, and small teams being able to go further without any specialist techniques and tools.
Building the next games.
Building, yeah.
I can't.
You
I
have
can't
to do
stay
the
away
puns,
from
don't
it.
you?
I can't. It's terrible. I know. Excellent. So if people want to learn more about SpatialOS, spatialos.com, like you mentioned, GitHub has the Hello World sample there available for you to do. If people want to reach out to you on Twitter or email,
Yeah, go ahead. And I say like the forums of SpatialOS are really active and definitely worth checking out. And the demo I ran through today is actually the exact demo you use when you sign up for SpatialOS. You get access, and you kind of go through your first kind of Hello World tutorial. You'll be running through exactly what we ran through here. But the next step is deploying it onto the cloud and then sharing it with people.
Excellent. Well, so if anyone has any questions, there is a microphone standing right there. So if you could come up to it and if you could ask your question so it can get on the recording, that would be great. But otherwise, thank you very much to Rob.
Yeah,
I really
thank you very much for having me.
time. Do we have any questions?